Okay, now I just want to show you a couple things that you could do with the calculator and sequences. So I guess first, since we just did factorials, we can look at the factorial button. So let's just do 5 factorial. Alright, that should equal 120. If we look over here next to the G, we got that question mark, exclamation point. Alright, that's not for writing essays on your calculator. That I don't know what the question mark is, honestly, but the exclamation point is for factorial. Alright, so there's that. And just want to remind you that you can make functions and you can use for sequences. So let's say that you were doing like a sub n is equal to, like you had an nth term formula and it was equal to, let's say, n factorial divided by n, I don't know, and you wanted to find the first 5 terms. So you would just do a sub n, or whatever you want to name your function. Whatever the inside letter is, that's going to be your independent variable. And we need to do colon equals here. Alright, and that button is next to the 9 in blue. Alright, so we hit equal. So the first term would be 1, the second term would be 1, the third term would be 2, the fourth term would be 6. Alright, so that's how you do that. Next thing. Okay, I just hit pause without noticing and gave a beautiful explanation of recursive sequences and calculators, but it's gone forever because I was just talking to myself. So let's try it again. Now I see it's recording. So hit the home button and then open up a new graph. And then add a graph, and I'll show you how to graph sequences. So you're going to go menu, graph entry, and then down to sequence. And then just sequence. Okay, so for just a regular old sequence that is not recursive, alright, let's just make it 2n minus 1. We're going to type the formula in there. Alright, initial terms, that's just if it was recursive, so we're going to leave that blank. And then the step, that means you're going to start at the first term, and this means you're going to do the first 99 terms. Alright, if you want to do the first 9 terms, you could switch it and do that. Alright, and then it shows you the first 9 terms graphically. Now notice how this is just dots. That's because sequences aren't continuous. So like it's defined for all positive integers, the domain. So 1, 2, 3, 4, 5, but nothing in between those values. And you could trace this, and you can see, all right, on the first term the value is 1. On the second term the value is 3. On the third term the value is 5. All right, so on and so forth. So that's another way you could find certain terms. You can graph it instead of defining the function. All right, now if we hit tab and we want to do a recursive function, all right, now since it's u2 of n, for the Fibonacci, let's do the Fibonacci sequence. I'm going to do u2 of n minus 1 plus u2, that's what the function's called, right? Like the band u2, of n minus 2. Alright, so it's going to take the current term is equal to the previous term plus 2 terms ahead of it. Alright, now we need to do initial terms, so it's a Fibonacci sequence, so we'll do 1 and 1. Alright, and let's just find the first 99 terms. Hit enter, alright, and we see that, okay, cool, we got the Fibonacci sequence. So when we trace it, alright, up and down we'll switch to different functions, left and right we'll switch to terms. So the green terms are fixed, those are the ones that we gave it, 1 and 1. And then oops, what's happening here? So the third term would be 3, the fourth term would be 5, the fifth term would be 8, the sixth term would be 13, the seventh term would be 21. Alright, so that's just a cool way to graph a sequence and a recursive sequence at that. Alright, so that's it for this video. We got one more page to go in the notes.